All right, guys, so today we're kind of putting together all of the shapes that we've learned and talking about geometric probability. You already know what the general concept of probability is. So for an example, what is the probability that you are going to roll a 2 on a dice? What is it? 1/6. You have a 1 out of 6 attempt. What if I asked you what the probability is that you would roll an even number on a dice? 1/2, 3 out of 6, right? So you already know what that concept is to have probability. Now, instead of talking about what's the probability of getting a number, we're talking about the probability of like landing in a certain space. So for an example, take a look at this drawing. So you can see here that you've got a big quadrilateral is the total space that we're trying to aim for, right? And I'm asking what's the probability that we're going to land in N. So when it says probability that X is in N means that if you were to take some point X and just throw a dart somewhere at this thing, what's the probability that it will land in that white circle? And it's just what you would think it would be. The probability of landing in the circle is what is the area of that circle out of what is the total area, right? Now keep in mind that we've found the areas now of triangles, quadrilaterals, any regular polygons, so regular pentagons, hexagons, octagons, blah, 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 right? We also now know the area of circles. So I could use any of these shapes and expect you guys to be able to find the area. That's the hardest part. All you have to now do in this section is take the area of what you're trying to hit, find that, and put it in a fraction over what is the area of the total shape. So I'm just going to do a couple examples with you. For this one, okay, we're told that each circular hole on the target has a radius of 1/2 foot. If a beanbag is equally likely to land on any point in the target, find the probability that the beanbag goes through one of the holes. Okay? So, when I am writing the probability of this, what is my fraction? What am I going to find for my fraction? What goes on the top of my fraction? What goes on the top of the fraction for probability? Remember, you're doing a probability as a fraction. What goes on the top? Area of what? Area of what you're trying to hit. What are you guys trying to hit?
Those circles, man.
How many circles do you have?
4.
So then you should be trying to find the area of 4 circles. What goes on the bottom? The area of the rectangle. Okay? Now none of these, once you've got this fraction set up, none of these computations are really all that difficult. So we know that we're trying to find 4 areas of circles. What's the formula to find the area of a circle?
Pi r squared.
Pi, what's your radius?
4.5.
0.5, so that was just in the reading here, right? It said the radius of each circle is 1/2 foot. So we'll do 4 times, and I'm actually going to write this as a fraction.
Why would we do that?
You'll see. Good question. I'll explain why I put it in a fraction in the next step. You don't have to. I'm just doing it because it makes my computations a little bit more manageable. Okay, area of the rectangle, how do you find that? 3 times 4. Okay, so now somebody asked, why did I write the 1/2 as a fraction? Well, think through this really quickly. What is 1/2 squared? What's a half times a half?
1.
Half times a half. What's half of a half? A what?
4.
A fourth, right? Everyone see that? Half times a half is the same thing as half of a half, which is a fourth. Well, if I have a fourth here, and I'm going to multiply it by 4, what happens? It's a whole. So really, this computation right here with the 4 cancels out the computation with the half squared.
So it's just pi squared.
It's just pi, because the squared only goes onto the radius. So this is technically just pi over 12. And then, depending on how they ask for the solution, you might give it as a decimal, you might leave it as pi. If I ask for this as a decimal, you should get about 0.26.
And is that for the circles? Like that's the answer?
So this is the answer. What does this mean? This means that I have a 26% chance or probability of landing in a circle. Okay, does anyone have any questions on that? No? All right, ready for the last example then?
Sure.
All right, so for this problem, I want to find what is the probability that if I choose any random point on that rectangle, that it will land in the shaded region. And I've given you some dimensions there. Okay, so first, before you start freaking out about the picture, start looking at what do I need to find in order to give the probability of this thing. So probability in terms of a fraction, what am I finding on the top of my fraction? What shapes am I trying to find for that? The triangles, right? I'm trying to land in the shaded region. So then I should be trying to find the area of those shaded regions, which means I have two triangles. What do I put that over?
Square, rectangle.
The area of the whole thing, which is a rectangle. Okay? So now it looks like it might be kind of hard to find the area of one of those triangles, but it's really not. If you take a look at that picture, I think it's easiest if I count this side as the base of my triangle, and then if I try and find the height just by drawing in this line right here, right? Because all I need is a base and a height for the triangle. Now something that I didn't draw here, but that we're going to assume is that this is the same exact triangle on this side. So they look congruent, and we'll assume that they are congruent. Can anyone tell me what the base is of the triangle then? 16 because of the 8 and the 8 over here, right? So the base of the triangle is going to be 16. Now take a look at the height. You know that the total distance from here to here is 24. We've cut a chunk of 8 out of the middle, which means how much of the 24 is left? 16 is left, and I know that I want them to divide evenly between these two triangles, right? So how tall is each triangle? Each of those has a height of 8 as well to add to 24. So now I have all the information, and it's really not so bad to find this probability. So I've got two areas of triangles, and the area of one triangle is 1/2 times the base, which is 16 is the base, times the height is 8. And again, I know I'm looking at that sideways, right? So I'm calling this the base and this the height. That is all over the area of the rectangle, which we will do 16 times 24. Now you can either type that out on your calculator or you can start reducing in here. So some things that I'm noticing is that half of 2, so this 2 and the 1/2 cancel each other out, right? I'm also noticing that I have a 16 on top and a 16 on the bottom. What does that leave me with? 8 over 24, which simplifies to 1/3. So I have a probability of 1/3 to land. What is 1/3 similar, or about approximately in terms of percent? 0.33 repeating as a decimal, but as a percent? 33.3 repeating percent, right? I will typically be asking you guys, I can't remember what the book does, but just be prepared. I will be wanting on quests a percentage answer. I want you to show me that you understand what it means in terms of a percent. So I would do that on the homework even if they don't ask for it, put it in terms of a percent. Are there any questions on what your overall goal is here? Again, the hardest part is going to be finding the area, but that's just practice of what you guys have already been doing, right? So the only step that is new here is setting up this original fraction of understanding what needs to go on top and what needs to go on bottom. You only have 3 homework problems. I would get out a book. You've got 7 minutes. You can probably get through one of those problems, if not start on a second one out of the 3. Okay?